Alrighty, guys, how's it going? So, the first thing I want to do today is start by teaching us how to graph a system of inequalities. So, I have four examples to show you. It's going to be a relatively short video, hopefully. We'll see what happens. So, first of all we're doing is really graphing inequalities, but we're graphing two of them on the same graph. So, let's just start with the basics. So, we have a negative 2, that is our y-intercept at negative 2. Then, using our slope, it's the number 1. So slope is in front of x, so our slope is 1 over 1. You want to make it a fraction, so we can go rise over run. So I'm going to rise up 1 and go to the right 1. And that is it. And I'll just continue that pattern, up 1 over 1, a whole bunch of times. So here's the next setup, is you're going to notice the inequality is underlined. That means, I could probably zoom in one more time, get away with it. Yeah, there we go. So you'll notice this inequality is underlined, meaning it's a solid line. So when I draw this, I should be drawing a solid line. Next, you're going to notice the sign. If you read this, it says y is greater than or equal to. So y is bigger. Greater than means to shade up or down. Well, greater than would mean to shade upwards. Down would be less than. So greater than means up. So I'm going to take my line and I know I'm going to shade everything this direction. Now I'm not going to shade it all in yet because I need to know what the other line does as well. So for example, our second line crosses the y-axis at positive 2. There it is. And slope is 5. As a fraction, that's 5 over 1. So I'm going to rise 5 and run 1. So I need to go up 5. 1, 2, 3, 4, 5, and over 1. That's kind of off the graph. We're not comfortable with it. So what's the opposite of going up 5 and right 1? Well, we can go, instead of up 5, right 1, we can go down 5. 1, 2, 3, 4, 5, and left 1. That would still be on the same line. And we also know that this line is dotted because you do not see it underlined, the inequality. So this is a dotted line. Looks like so. And let's look at what it says. Y is less than, meaning it needs to be shaded to the, or sorry, shaded up or shaded down. If it says less than, that means we're shading it downwards, which would be this direction. So the question is, what part do they have in common? Well, when you look at the shading, both of these are going towards each other. So this whole section, I'm going to color it in lightly. This whole section is what they have in common. And so if somebody asks you what the solution is, or is something a solution, any point that falls in this shaded region is a solution. And that is it. Any point that is not in this shaded region, like something out here or down here in this little space, is not a solution. Only where they both have it in common. All right, let's try again. So number 2, we'll go faster. This is +1 on the y-axis. I then go rise over run, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Again, we could also go down 1 to the left 2. All right, I see that it's underlined, therefore it should be a solid line. And it says it is less than, so I should be shading downwards. Next, second equation says +3, so I should be right here. And the slope is -1 over 2. So that means I go down 1 to the right 2. So down 1 to the right 2, down 1 to the right 2. And this one is also underlined, so it should be a solid line as well. And it's a less than symbol, so I should be shading downwards. So here's my graph. Using the less than, we're shading down. So the question is, what part is shaded in common? Well, this part is shading downwards. and this part is shaded downwards. So it is everything right here that they both have in common. So I'll lightly color that in, not to overdo it. So any point that is in this shaded region is a solution. Now, I don't want to get into details on this, but if you pick any point from here and you plugged it back in for x and y, it would make both of these equations make perfect sense. For example, when we're done plugging it in, it might say something like 2 is less than or equal to 5, which makes sense. And this one would say the same thing, like 2 is less than or equal to 7. It would be two true statements. All right, moving on to our next equation. Of course, we had to throw in standard form because we struggle with that. So if it's written in standard form, just put it back into y equals form. You would do that by subtracting. First, we would subtract x from both sides. So I'm going to go ahead and write it up here. X plus 2y is less than negative 4. Well, I would first subtract x from both sides, leaving me with 2y is less than negative x. Remember, two separate pieces, negative x minus 4. And then I would divide both sides by 2 to get y by itself. Now remember this step, if you ever multiply or divide by a negative number, the sign flips. But we're dividing by a positive, so it is not. So y will be less than negative 1, invisible 1, right? So negative 1 over 2. And then negative 4 divided by 2. And there's our equation. We'll graph that in a little bit. Let's solve the other one. The other one can be solved in one step. You would subtract 3x from both sides, and y would be less than negative 3x plus 3. Negative 3x plus 3. And there's our two equations. Okay, we're going to notice that both of these inequalities are not underlined, therefore they're both dotted lines. So let's start with the first one, negative 2. There it is on the y-axis. I am now going to go down 1 and right 2. And there it is. I'm just going to repeat that again. And again, you don't want to go down 1, right 2. You go up 1 and left 2, just to make sure you get it all on the graph. We just said it's a dotted line because it's the inequality itself is not underlined. And it says less than, meaning we should be shading downwards, down to the ground. Okay, next equation. Less than negative 3x plus 3. Well, the plus 3 is where we start, 3 on the y-axis. And now my slope's negative 3, like negative 3 over 1. So I'm going to be going down 3 to the right 1. Down 3 to the right 1. I'm going to repeat that, down 3 to the right 1. So it's a dotted line again because it's not underlined. So down, dotted, 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 all the way through there. Okay, that was an ugly straight line. And then it says less than, so we should be shading this way. Now, what section of the graph do both of these share in common? Well, this line's going this way, and this line's going this way, so that is a mutual area that they have in common. All the way to here. There we go. So any point that falls under this area would be considered a solution. All right, last one for the day. We have x minus y. We'll go ahead and solve that. That takes about 2 steps. Our first step is to subtract x from both sides, because remember our goal is to put it back into y equals mx plus b. So we still have negative y. It's still greater than or equal to, and it's negative x plus 1. Okay, important step here. It's a negative y, meaning negative 1y. So we can get rid of a negative 1 by dividing it by negative 1. And we just talked about this. If you ever divide both sides or multiply both sides by a negative number, the sign must flip. So you'll notice the sign is flipping. And we end up with a positive 1x, and 1 divided by negative 1 is negative 1. Okay, next equation, we would start by, I'll just rewrite it. So we would start by first subtracting x from both sides, leaving you with just 3y is still less than or equal to negative x plus 9. Final step is to divide by that 3. Y is less than or equal to, because the sign will not flip, we divide it by a positive number. So that becomes negative 1 over 3x. And 9 divided by 3 is 3. Okay, so now we're going to go ahead and graph these and call it quits for the day. So first equation started at negative 1. Our slope is 1. Remember, the 1 that's in front of x as a fraction would be 1 over 1. So rise 1, run 1. Rise 1, run 1. And I'll just repeat that a couple times, make sure we're good. Okay, you'll notice the inequality is underlined. So if you see a solid line, it is a solid line. And it currently says it is less than, meaning we should be shading downwards. All right. Second line starts at positive 3. There it is on the y-axis. And we're going to go down 1 to the right 3. Down 1 to the right 3. There it is. And it is a solid line as well because it is underlined. Okay. Next, we shade it in. It says less than, so we should be shading downwards. So what part are they shaded in common? Well, they both have this area shaded. Any point that falls under this shaded region is a solution. Alrighty, y'all. If you want to see a prettier picture of all this work that I did, let me zoom out real quick. Maybe one more time. So if you want to see a prettier image of all this work without all the scratch and mess, let me just zoom in a little bit. So they kind of, you can see they shaded in the regions for us. They shaded in the bottom here and this, oops. And then on this example, they were both dotted lines and they shaded them in. Just like we have in our photos, just theirs is much prettier. Alrighty, y'all. I wish you the best of luck on your homework and let me know if you have any questions.